Hi all, I thought I would share a relatively brief and simple overview of the nature of science. There are certainly some very good videos, including some that I've done myself, that are much longer about this topic, but I wanted to try and be as quick, clear and concise as I could. So let's see how we go in doing it quickly. There are essentially 7 elements that I want to talk about briefly about what science is as a topic and how science works, how we operate when we're doing science and learning science and coming to understand science. So science knowledge, scientific knowledge, is empirically based, that is based on evidence and things that are measurable. So it's a domain of human knowledge. It's not all of human knowledge. There are other forms of knowledge that are not based on evidence in the same way. So our appreciation of a ballet or poetry performance, for example, is based much more aesthetically and on its emotional impact on us than it is on empirical evidence. So, and those are perfectly valid forms of human knowledge. So science is that subset of human knowledge that is based on empirical, measurable, physical world evidence. At the same time, though, not everything can be directly measured. Some things we have to measure indirectly. So the properties inside the atom, where it's much, much too small for us to see, we have to infer what's going on with the protons and the neutrons in the nucleus of the atom. To take a slightly different example, the center of the Earth, we believe to be a solid core of compressed metals and other substances, which is surrounded by a core of an outer core of liquid metals and rock and other substances. But we haven't directly been to the center of the Earth to explore. It's too far, it's too hot, it's too compressed and extreme. We're unlikely to ever go to the center of the Earth. So how do we know what's going on there? We've inferred it from looking at the patterns that the waves, the seismic waves from earthquakes, make when they travel through the Earth and come out the other side. And that's allowed us to infer what's going on. So there are some things we can measure directly, other things we have to make inferences about to understand what's going on. Scientific knowledge is tentative in the sense that it can be overcome by better scientific knowledge. Now, that doesn't mean all scientific knowledge is just a guess and anybody's guess is as good as anyone else's, but it means that an older theory, like Sir Isaac Newton's theory of gravity, can be replaced by a newer and better theory like Albert Einstein's theory of gravity, which was more powerful and applied in more places and worked better. So scientific knowledge is the best knowledge that we have currently, but it may well be replaced by even better knowledge, which is what science is, the activity of seeking better understanding of the world. So scientific knowledge is our best current understanding that's best supported by the empirical evidence we've collected so far, but new evidence or new ways of thinking might replace it with an even better scientific idea. The idea that the Earth was at the center of the solar system worked for some time. It helped explain why the sun apparently moves as it does and the moon apparently moves as it does. But once we started looking at the solar system more broadly, the idea that the sun was at the center of the solar system explained things better. So we moved from this Earth-centered to a sun-centered perspective because it was more powerful. It explained more of what was going on. Science involves facts, theories, and hypotheses. A fact essentially is something measurable. So if I were to drop my pen, it would fall toward my desk at about 9.8 meters per second, and that's a measurable fact. If I had a stopwatch and some means of measuring the distance, I could measure that right now. A theory explains a fact. A theory has descriptive power. It can describe the world around us. It has explanatory power. It tells us why things happen. And it has predictive power. It tells us what might happen next time I drop my pen. So theories are these structures of human thought that explain the various facts that we observe. A hypothesis is essentially a prediction made by a theory that we can then test experimentally and see whether it supports the theory or not. If my theory was if I had a hypothesis that next time I drop the pen, it will go upward instead of downward, I could test that and very quickly discover that no, that particular hypothesis is not supported by the evidence, and therefore it's rejected. Facts don't become theories, theories don't become facts. Even a theory that's very well supported by evidence over a long time is still not considered a fact because it's not directly measurable. A theory is a mental construct that explains things. So those two things are different, and it's important to understand the difference between them. And science involves all of those things. Science is intersubjective. So very briefly, objective means true everywhere for everyone. Doesn't matter who measures it, it's exactly the same. Science is not quite that kind of thing. The physical world, we can argue, is objective. It's the same no matter what, but we don't have direct access to that. And science, anyway, is these scientific theories, these ideas about understanding the world and explaining the world. And so they're not purely objective. They're also not purely subjective in the sense that one individual can have their own private science. It doesn't work that way. Science is a collective human activity. Science is intersubjective because it happens between people within community. So a theory is advanced and then it's tested by other scientists who come to accept that theory as the best explanation, and that becomes the current scientific understanding. It's that communal social process of activity that tests a scientific concept and makes it the canonical, the accepted, the shared scientific understanding of how the world works. So scientific activity is, as I say, not purely subjective and private, individual, not purely objective, independent of all people. It's this intersubjective nature of between people that constitutes what we do when we're doing science. Science is creative, it's imaginative. Sometimes we hear about the need, the arts being creative and the sciences being very mechanical and locked down. No, science necessarily involves creativity, necessarily involves imagination. Einstein said imagination is more important than knowledge. And certainly in developing his theories, he imagined what was happening in different times, different places in the universe, and then was able to then move into the mathematics and calculate out his theories in some detail. So the imagination by itself wasn't enough. He also needed some knowledge. But he was suggesting that the imagination comes first, that scientific advances are this creative process that we then take to test and then we then structure with theory and so on. So it's a really important part of the nature of science is this creative activity that we do. And finally, science is something that's embedded in culture and society. It's not something that's separate from humanity and the rest of society. This relationship goes in multiple directions. Society makes ethical decisions. Is it appropriate to build artificial intelligences that are more intelligent than human beings, for example? Is it appropriate to use animal organs in transplants into human beings? Is it appropriate to clone human beings, for example? There are a number of issues that are ethical issues, and science itself, from inside itself, doesn't really have a solution to ethical issues because those are not empirical questions. So society, culture, needs to consider those ethical questions and inform science in that way. Science informs society in terms of ideas and in terms of metaphors. Ideas about quantum, for example, and relativity have kind of influenced our thinking in the arts and in the humanities and the ways that we think about the world. Science informs technology and technology informs science, and both inform society. So society is influenced by our technological tools and toys and the things that we do with them. So science, technology, and society are in this complex and dynamic relationship. So I hope that's a relatively quick and a relatively useful outline of what we mean when we talk about the nature of science.